Alright guys, so I'm back and we're going to do the second part of this first lesson on kind of vectors and right triangles. So we just finished the right triangle review. If you didn't watch that, go back and watch that video in part 1. So now we're going to get into part 2, which is dealing with what is a vector. So again, you have a basis for vectors already with displacement and velocity and acceleration. So a vector is a measurement with a number, unit, and direction, and many concepts we study and will study are vector quantities. So force is the unit that we're currently in, and that is a vector quantity. So we need to be able to do the math. And in motion, we focused on one-dimensional motion, so we didn't really have to do a lot of like right triangle trigonometry when dealing with vectors, but we are going to have to do that in this unit. So vectors require math that incorporates direction in the calculation, and that's right triangle trigonometry. And we just went through that review. So we already talked about this, the hypotenuse, the opposite, adjacent, we've done all that kind of work. So a vector, again, is represented by, in pictures, is represented by an arrow. And what's good about using an arrow for a vector, if I had vector, these two vectors, vector A and vector B, I could ask you, okay, which vector is larger? And you would say that vector A is larger than vector B. So it has a larger number or magnitude. And we could measure in any units here. So when we measured velocity, it was meters per second. If it was acceleration, it was meters per second squared. We're going to measure force, which is measured in newtons. So it'll be some number of newtons. The other thing that arrow provides you is a direction. So if I asked you which direction are vector A and B going, what would you say? And hopefully you came up with that they are both pointing to the right. So again, vectors and arrows easily tell you the direction. So this vector C would be going up. They're not always just in one dimension. Sometimes you have vectors like D here, and that is where we're going to have to get into some right triangle trigonometry. So hopefully you can see how this would translate into vector D is going up and to the right at some angle that we would measure from our coordinate system. Sort of very similar to this triangle. And what we will do is we will break this up into like parts. So there's a part of vector D that goes to the right, and there's another part of vector D that goes up. So that's going to be the x and y components or parts or pieces that go along with vector D. That's supposed to be a D there. That's a letter D. Just like in the last video, if we know the length of the hypotenuse, which is the overall size of the vector, and we know the angle, we can figure out, how far vector D goes in the x direction, dx, and how far it goes up or down in the y direction, which is dy. We're going to use our standard coordinate system again, so we've already established this with motion, but just reminding you guys, positive x is to the right, negative x is to the left, up is positive y, and down is negative y. So hopefully you guys are good with all those concepts, and this should be fairly straightforward. So the first couple examples we're going to do are really basic. So the first one here, we have this vector I'll call vector A, and the second vector here is vector B. And we're going to try to add vectors together. So what I mean by add vectors together is basically you just get the overall result if you had those two vectors put together. So let me do something here to make it a little easier to see how this is going to work. And we can do vectors graphically, but it's easier to do the trig, so that's why I teach you that. So let me just take a quick snap here. So if that's vector A, and that's not the right size, so that's going to annoy me. So anyway, let me try it a different way. Use a different snipping tool. Maybe that'll work better. All right, still good. So I'll try to make them the same size. All right, so that looks pretty close. So if we had this as vector A, and I'm going to have vector B is the same, so I'm just going to copy and paste it. And we're going to put them like on top of each other. So we're going to add them together. We want to figure out what is the overall resultant vector, which is the sum of those two vectors together. So it's like from where I start, and you kind of remember resultants from the idea of displacement, to where you finish. So that blue arrow would represent the total vector sum of vector A plus vector B. So I'll just call this R, vector R. And this one, again, is really straightforward because they are pointing the same exact direction. So if you had vector A, which is 5, and vector B, which is 5, and they're both pointing to the right, what do you think vector R is going to be? It should be 10, and it would be going to the right. I didn't specify the unit here on this example, so let's just say everything's going to be measured in newtons, because that's the unit that we're going to need to get used to for force. So it's like something's pushing to the right with 5 newtons, and another thing is pushing to the right with 5 newtons, and the total sum of those two forces together would be 10 newtons going to the right. Number 2 here is sort of the same concept, just slightly different. So if you take a look at that, we have one vector, which is like a positive 5. Maybe we'll call that vector A, and we'll say it's in newtons again. And vector B is a negative 5 newtons. And we want to know what is the sum of those two vectors. So I'm going to grab these again and use them. Not that. That's what I want. Okay. So if that's vector A, and that's vector B, what do I need to do with vector B? So if I start vector A here, if I put vector B goes to the left, so I'm going to flip it and see if I can do that. Okay, so if I put them together, and I want to try to do this as well. You can see that when I add those two vectors together, it looks like I don't go anywhere. So I started here, I went to pushing right 5, I'm pushing left 5. If you imagine it's like a tug of war, which is a good way to kind of examine forces, those two forces are just going to balance each other out. So this net force between those two would be 0. So there would be no result. They would be balanced. Okay. So the last one here, the last couple, deal with things that are at angles. So this is, we got two vectors, maybe vector A and vector B again. And you can see this is more of a right triangle scenario. So we're trying to find the resultant vector R. And we always measure, in this class, we always measure our angles from the horizontal. So to make it easier, I just consistently do that with all of our measurements. So I'm going to draw in an axis here. I'm going to change the color so it shows up. So if this is a horizontal axis and this is our vertical axis, you can see that we're going to measure our angle here. So that's going to be theta. So we're going to basically turn this into a right triangle and make it so that we can solve for theta and we can solve for r. Just to use for later on, because we're going to do the next problem too. I'm going to copy and paste that, make that come over to here for the horizontal, and I'm going to copy the vertical one as well, and use that here for later on. So just to get used to seeing that here. All right. So so what I'm going to do is I'm going to say, all right, I'm going to do these addition, and the way that I do vector addition is called tip to tail. So you put the tip of one vector to the tail of the other one, and both of these pictures are already done that. And we're going to kind of establish the sides of this right triangle. So if you look at this right triangle, it's going up and to the left. Another way you can call this, if you look in the book, it's called the parallelogram method. So because it makes a parallelogram has two sides are parallel in each shape. So that's what we're doing. So we have that side that goes up and this side that goes to the left. So this side, again, is parallel to that one. So these are equal lengths. So that's 10 and 10. That's 5. So this is 5. So I have a right triangle here with theta inside of it, where r and theta is what we're looking for, where the sides are 10 and 5. So again, like we did in the last video, we're going to identify what's what. So this is 90 degrees because that's the horizontal and vertical are always perpendicular to each other. Theta is equal to, across from theta is the opposite side. So 10 is the opposite. So I'll write OPP to make it so you don't get confused with a 0. So that's the opposite side. And then the adjacent side, ADJ for adjacent. is the adjacent side, because it's not the hypotenuse, which is the resultant vector. The longest side that's across from the 90, it's the third one. All right. So again, the math isn't so bad once you get that set up. So we're going to solve for r, which is the length of that vector addition or vector sum. So it's going to be, a squared plus b squared equals c squared. So it would be 5 squared plus 10 squared equals, I'm going to use r because that's the letter that we use for the resultant vector squared. Right? So if we do this math, 5 squared is 25, 10 squared is 100, and that's equal to r squared. So you're really trying to get the square root of 125. Shrink this down so it's a bit better. There we go. So 125 equals r to the second power, and you're going to take a square root. And if you put that in your calculator, and hopefully you can do that fine, you should get r is equal to, where do I have it? 11.2. So that makes sense. 11 squared is 121, 12 squared is 144, so it's in between those two. And again, we're going to call everything newtons right now, so that's supposed to be an r. I don't know if that looks like an r so much. That looks more like an r now. So r is equal to 11.2 newtons. That would be like the net force out of those. The other thing we have to do is solve for theta. So we did this before. Solving for theta, you have to find the relationship. We're going to use the tangent because that's the easiest one, I think, to identify with, and you don't have to worry about, like, oh, did I write something down wrong, or did I calculate this value for r wrong? So tan of theta is what we're going to use. And that's equal to the opposite side over the adjacent side. And I'm going to type again because this is really sloppy. Sorry about that. Let me type that out. So if I'm doing this as a fraction, the opposite side was 10. So it would be tan of theta, I'm just going to write out theta, is equal to 10 divided by 5. And then I want to get theta all by itself. So theta is equal to tan negative 1, or arctan, remember, of 10 divided by 5. And if you do that, that answer is like 31.8 degrees. And the last thing we have to do is describe where that angle is going. So what we always do is we describe it as either above or below, and then it's whichever x-axis is going along. So if you think about, we're starting here and we're directed up and to the left. So up and to the left, up means it's above. Let me shrink this again. There we go. So up is above. And it's pointing to the left, so that's the negative x-axis, so it's above the negative x. You're not going to have to, I think, worry about this too much in your problem solving in this class. It'll be more likely like I will give you a force at an angle and you'll have to solve for the x and y components, but this is good practice anyway, so that's for number 3 there. For the last one, 4, we'll work through similar steps again. So let me move this because I put that in the wrong spot. It should be more like this. Okay, so we start at the origin. It looks like we move along vector, whatever letter you want to call it, so we'll call that A. So if that's A is the 30, we'll call B maybe the 40. And then we're looking for R, so we're looking for the resultant. We're looking from where we start. Vectors always go from start to finish. And that is not a good one that I drew in, so let me try to draw a line. That is better. So, we'll call that side of the triangle R, and we're looking for R, and we're also looking for theta, and I don't have a theta key handy, so I'm just going to write a theta up there. So we're looking for that angle theta. Right? So from the horizontal going to the result. So our resultant vector points kind of down and to the left. That's what we got. And let's go ahead and solve for the size of R. So it's, again, really similar to what we just did over here. It gets very repetitive. So I'm going to copy and paste that and then just fill out different numbers. So our first line here would be a squared, so that'd be 30 squared, plus b squared, which is 40 squared, equals r squared. So 30 squared is 900, 40 squared is 1600. So if you add those together, you get 2500. And then you want to get r. So again, you take a square root, and r would be 50. We'll say it's newtons again. So there's just the Pythagorean theorem worked out for that portion. Hopefully that is the easier part of the two, I think, for most people. Remember, you got to take a square root to get to r. So the other part here is solving for theta. So again, I'm going to copy and paste because it's, again, very similar. That's good. It's a good size. So we're just going to change up the numbers. So tan theta. We didn't do the other part. I just assumed. So so r is my hypotenuse. Theta is across from the opposite side, so b is the opposite. That's supposed to be a p. There we go. And then a here is my adjacent side. Hypotenuse. Just trying to make sure we label things. You should do that first, really. With the Pythagorean theorem, it's usually pretty obvious as to which one is the hypotenuse. So we just have to change out the values in this expression now. So the tangent is the opposite over the adjacent. So the opposite side would be the 40, and we're going to divide it by 30. Okay, that's going to get us a different number, and it's going actually a different direction, so I'm going to take that off too, and we'll talk about that. So when you put that in your calculator, and you can check it yourself, but you should get 53.1 degrees. And we have to decide where this is going. So again, we're starting here, and we're going left and then down. So if I'm going down, that's the opposite above, so that's below. And this vector moves, so r goes down and to the left. Left is the negative x. So so that's how you come up with those values. So hopefully that's a good stopping point, and that'll be enough to get you through the vector math that we have to do. Sometimes we'll have really basic vector math, and we're always going to try to make it so it turns into things that it's like left or right, or maybe we would have these and we would rotate them kind of 90 degrees. So it might be going like that, and this one might be going down. So again, like, you're going to be able to see how they combine and calculate them fairly straightforward. So we'll get into that in the next couple lessons. So have a good one, guys. Be well.